Okay, let's start. We are enough to start. And first of all, good morning, everyone. And first simple things that I want to tell you this morning are these. Let me adjust the camera. So probably you know already. Let me check. Camera. Okay. So probably you already know, but good morning. And probably I was saying you already know, but since yesterday you can re-watch videos that we will stream live for 24 hours, and probably my videos, because probably I will start deleting them probably for a couple of days more. And this is pretty helpful because you can watch them even in slower speed. You can go always back and forth. If you know some softwares, you could download them, and this is first. Second, I want to share with you now, and I will send the link into the chat, the folder where you can upload your inventor homeworks. Now I will write it into the chat, but then when I will finish this live stream and I will basically publish this video, I will add link in the video description. So if you are not viewing this video live and you need to upload your homeworks tomorrow and so on, you will find the link. Link in description, like real YouTubers used to say. So let me share the link right now, because it looks complex while it is not. So it is a Google Drive folder. So I need to make it, I have to share these. Okay. So try this. I'm doing these. Perfect. You can see also the link in the video. And to upload, follow this link. Boom. If you don't mind, if you have something that you have already prepared, just try to open this link, and you should be able to simply drag and drop your files inside this folder. And just to avoid confusion and to avoid making multiple folders, what you have to do is I will create this folder for Inventor class, and you will be so nice to rename your files like homework 1, homework 2, homework 3, and your name next to it, so that basically you can also add this folder in your favorite bars, and you can always use this folder to upload your homeworks even in next weeks. Okay, if you also are so nice that you try to upload, at least one of you, if you want to try uploading your homework, you will give me a real-time feedback in understanding if it works or not. Honestly, I already tried yesterday for other classes, but I know, because things happen sometimes. So just give it a try and let me know if it works or not. Okay? Okay. Also, when I look like I'm stuck is because there is a delay between when I speak and when you see this on YouTube. So, I mean, it's not that the video is not working. Okay, let's pretend that that everything works, and if it doesn't, in the meantime, let me know into the chat. So, what we have to do today? Today we need to see again Inventor modeling tools, and I want to show you a very interesting family of geometries that you can create in Inventor. This is why. Simply because today I will give you your first free project. So instead of copying something that is existing, I will give you one, maybe two, I would say 2 weeks to develop your own simple project, and I will reveal this at the end, because if not, I mean, I will just keep the suspense. And so, which kind of family we have to study today? That is very simple. We are still talking about parts. Take care. And I want you to develop your own product, simply because starting from next week, I will introduce instead the concept of using assemblies in Inventor. And in this way, you will have not only my lesson, and you won't use only just abstract geometry forms to play with, but you can also try by yourself in your own objects, applying concepts that we will study. So, don't digress, and let's see, by opening a new part, let's see what we have to study today. That is very interesting, because, okay, see this. Till now, we have studied in Inventor very uh, simple, not that simple actually. We have seen tools that are pretty precise. We have seen a lot of procedures that allows us to create geometric shapes with very precise steps to follow. So at the very beginning, what is main obstacle that new Inventor users find? Let me see. Let's see. Now you can also see my homeworks in the folder. Let's check in real time. Whoa. Oh, students project live stream should be this. Let's see. Inventor homeworks. Yes. We have homeworks, and this is the proof. Okay, so thank you so much for, yeah, and you can also see that yes, they are uploaded. You are safe. You will be the only one who will pass this class. And so let's see this. Uh, the tool that I want to show you is this tool here. At the very beginning, it looks like we have only something that is written box, and it appears with this kind of purple color. First of all, in reality, this is not true, because if you notice, underneath box button, we have a triangle. So if we click in this triangle, we can notice that there are more options. Okay? And let me tell you, what is also a little bit weird is that it is written box, but in reality, even the symbol doesn't look like a box, because it has smoothed edges, and it looks more like, if you remember, we've seen something like this when we have studied 3ds Max, and when I showed you the modifier that is called Turbo Smooth. So if you think for a second, it looks like this is a box that has Turbo Smooth modifier applied. And believe it or not, we are not that far from reality, because this is exactly what happens. This is a family of objects that is simply called freeform in Inventor. There is a category of objects that is not parametric. So instead of being something that is related to a sketch and to a tool that turns the sketch into a 3D object, freeforms that are basically starting like simple shapes, like boxes or planes or cylinders. Then we have sphere, then we have quad ball, that is basically a cube that is so rounded that becomes a ball. But all these shapes, instead of being related to a function, they are already three-dimensional objects, and they work exactly like editable poly in 3ds Max. So we will see that once that we create them, we can manage them by changing and modifying the position of their vertices, or their segments, or their polygons, and so on and so on. So let's see how they work, because this would be pretty phenomenal. There is this. Like any other object in Inventor, you need to start from a plane. So you need to start by selecting where this object is going to be placed. And again, I just start by selecting one plane. I select top one, and I start by making a box. So I click box, and you will see that you start by having this dialog box. In this dialog box, what is written is that you can, if you click, you can, even before creating your object, you can start by giving your box more precise dimensions. And also, what is interesting is that you can notice in this column of the box dialog box, dialog box, that we have not only dimensions, but we have also parameters that are called faces. And this again reminds a lot 3ds Max, because what here are called faces is technically what in 3ds Max was called segments. And what you find here is that right now, if you see dimensions on the left column here, you will see that this box will be 75 millimeters long and in this direction. It will be 50 millimeters long in this direction, and it will be 25 millimeters tall, that is this thing here. And this is what is written in this first column. How can we change these options? That's very simple. We can or simply change the number by typing another value inside this column, like I can write 50 here, 50. Perfect. And you will see your shape changing in real time. But if we are not 100% sure of dimensions that we want from the beginning, you may also notice that into the box you have 3 arrows. And when you select arrows, you can see that the direction that you are changing is also highlighted in your dialog box. So another way that you have to adjust your box main dimensions before creating the box itself is that you can also left click and drag these arrows to stretch your box. Okay? When you do this, you can also check in real time that by stretching manually your box, dimensions are updated in real time, so that you can always know for sure the newer dimension of your box. And let's delete these. Let's see second column. So what is this part in here? Faces are basically number of subdivisions that you find in all of your 3 directions. So you can see that length, that is this one, is divided into 2 faces. This would be number 1, this would be number 2. But also width is divided in 2 faces. So it is divided like this. And in this way, we can also manipulate how many control points we may need in order to adjust our box. This is something that is pretty easy to be made from the beginning when you create your box, but also if you change your mind, it is also something that you can do afterward, so after creating your box. And so, just to let you see, we can also add more faces along the length or decrease them. We can add more along the width or decrease them, more along the height, and so on and so on. Let's start with this very simple, basic setup that is just by having 2 and 2 faces for length, width, and height. So at the end, boom, we can just click OK. And what is great is that when we click OK, we are inside our freeform. And you will notice that now we have this new tab appearing. So we are not more in our 3D model, but we are in a very specific tab that is called Freeform, that contains main tools that we can use in order to adjust the shape of our 3D solid. Also, I've said 3D solid for a very specific reason. That is, you may notice that our freeform is a 3D object that has no gaps, it has no holes right now. So what this means is that when we will click finish, and we won't do this right now, but when we click finish, if our object is closed, if our object has no gaps, this, once that we will finish, this will be turned into a 3D solid in Inventor. So one of those gray objects that we have seen, we can also create and manage by using all of our 3D model tools. But, or if I start by making freeform as a plane, or if I delete some faces so that I make this object hollow, then this object will be turned into a surface when we go back to our inventor part. And having a surface instead opens possibilities that we have seen last week. So you can mainly use surfaces to trim solids, or you can use surfaces together in order to use that tool that is called sculpt. But what is the deal with freeform? Main, and let me tell you, most interesting part of using freeform is that once that you are inside freeform, first thing that you should do is you should click this big button here that is called Edit Form. When you click Edit Form, you will get this dialog box appearing. And what is interesting is that you have not to close it, but this is a dialog box that remains available. And basically what this is something that, again, if you are still remembering a bit of 3ds Max, you will notice that this is exactly what an editable poly gives you as editing possibilities, because in here we have that if we click this button, we will be able to select vertices of our object, and if we click this one, let me change the color because I don't like yellow. If we click this button here instead, we will select segments. If we click here, we will select faces. If we select this one instead, this is a little bit weird, but this is called all. So, just to recap, this is faces, and this one is called all. So, what is the difference? The difference is very simple, that is, if I click vertex, if I select even more than one object, I will select only vertices of my object. Okay? And the same thing, if I click edge, I will select edges, edges only. If I click face, I will select faces only. But if I click fourth method that is called all, according to where I click, and this is easy for vertices, and sometimes it becomes tricky for edges, but in this way, according to just where I click, I'll be able to select or vertices or edges or faces. But let me tell you, especially at the beginning, using these will be slightly a bit confusing. So, other things that we can do here are these. We can select the entire body, and this is like what in 3ds Max is called select the entire element. Or we can select loop, like if I select edge, I click these, and then I click loop. By making this simple click, I will immediately select a closed loop of continuous edges. This is what loop means. But now, see this, because this will be fantastic. There is. When we edit forms, and you can see that you are able to select elements like these, but you can do anything if you don't keep edit form active. So, but see also, and be so nice to check even the symbol itself of the tool. But look here, when I select an object, doesn't matter if I select a vertex, an edge, or a face. What is interesting is that on top of your selected object, you can see these big, beautiful symbol appearing. And again, let me highlight it. What is this symbol? Again, if you think for a second, you have already seen something like this when we have studied 3ds Max. And in 3ds Max, when we use transformations, you may remember that according to which transformation you select, there are 3 different gizmos appearing. There are 3 arrows for move, 3 circles for rotate, there are 3 axes for scaling. Well, believe it or not, this is the exact same thing, where these are the 3 gizmos shown together. So if you click here, here, or there, or these small parts, so this first set of 6 elements, and again let me highlight them because at the beginning this can be confusing, but this, sorry, this is too big, but these, and these, if you click with your mouse there and you drag, those are scaling on one axis. But if you click inside these, or these, or that, though, and you left click and drag, by clicking there you will scale your object in a plane, so in 2 directions at the same time, as well as if you click that tiny sphere that is in the center, you will make a uniform scaling transformation. So you will scale your selection in all 3 directions at the same time with the same factor. So this inner parts are basically the gizmo for scaling. What we have next? Next we have this arrow, and this arrow. Those are instead to move your objects. And if you click and drag on those arrows, you will move your selection in one or other axis only. While if you left click and drag by placing your mouse inside these three squares, you will move your selection on a plane. Last but not least is we have these three, no, not with the same color, let's make it yellow. So these are this arc and this one. Instead there are exterior symbols. Those are the gizmos for rotation. So in one, at the same time, basically we have all three available transformations. So if I simply do this, look, I select my plane and I left click in here, and you will see that I will be able to drag my selected face along that axis. But if I click this instead, I will rotate the face like this, or I can rotate it like that. And what is phenomenal, let me tell you, is that whenever you start adjusting your planes like this, something that is honestly a limit that 3ds Max has, and that instead in Inventor is not, is that you can be extremely precise like this. If I click move, I can see that I am selecting my y-axis, and not only I can left click and drag and I can move my selection up and down, but at the same time I can see that what happens is that in my temporary dialog box that appears up there, there is also a numeric field. So not only I can just randomly move things up and down, left and right, but if I just click on the axis, I can also specify the amount of the transformation by typing a precise value. So I can say that I want to move this face 3, let's say, millimeters by following the direction of the arrow. So I will just type 3, boom, and my plane has been moved 3 millimeters along the direction of the arrow. If I select this arrow, let's say, and if I type a positive value, I will type, I was saying, if I type a positive value, I will move this object up, for sure. So I can type 5, boom, and this goes 5 millimeters up. But if I want to do the opposite, so I want to move this object down, I will write simply minus, let's say minus 10, boom, and instead the plane goes down like this. This is a dialog box that is pretty interesting because it changes values that you type according to the transformations that you select. So what it means? If I select move, these will be the distance, and if I select the plane to move, you will see that because this allows me to move objects in X and Y, I will have two numeric fields. But if I select rotate instead, this value here becomes degrees. So if I type 20, it will be 20 degrees. Technically, it is anti-clockwise positive, clockwise negative. So I can also write minus 20. Boom, sorry, closed it. But this is what happens when, even for scale, look, if you click scale, this is your scaling factor. And scaling factor works more like AutoCAD. So you don't see a percent value, but you see a number that means how big your thing should become. So if you want to make it something that is 2 times bigger, you select scale, let's say uniform scale, you type 2, and this would be 2 times bigger. But you want to make something that is 2 times smaller, so you type 0.5, and this becomes 2 times smaller than it was before instead. And you will simply click OK when you want to finish your transformation. What we have also inside edit form as interesting function is that the pivot point works like that just by default. So what it means? It means that if I select a plane, the pivot point shows me directly the 3 available transformations. Why this is happening? Because sometimes it can be confusing. Sometimes you just want to move or scale or rotate elements of your freeform and you don't want to be distracted by additional options. So what you need to see in this dialog box is what happens here. This is the reason why the pivot point is behaving in that way. That is, again, by default, whenever you click Edit Form, you have by this symbol selected, that is Transformation All. If you need to be more precise, if you freak out when you see all these things in your gizmo, you can say instead, look, I click this second way, and this is move only. So in my pivot point, in my transformation gizmo, I will see only move transformations. Here, I will see only move. I can move 1 plane, 2 planes, but just move. Second will be just rotate. And scale only. Okay? So if you get confused because having too many tools at the same time will, again, it will be confusing, you can select these 4 methods. By default, take care, each single time that you click edit form, each single time, this is always selected. That is transformation all. So all of your transformations will be available at the same time. Then we have another interesting thing, that is which coordinates Inventor uses, because you can use, and this is not that simple at the beginning, but if you see again, by default you have that coordinates are these, that are world. What it means? It simply means that the direction of these axes perfectly match direction of Z, X, and Y axis. These are called world axis, world coordinates. But, and sometimes it is interesting, you can use this second method, that is view. So your axes are aligned to your actual perspective point of view. That is weird at the beginning, but sometimes it is helpful. That is like this. And what is interesting is that if you change your point of view, you will see that your coordinates will always follow the orientation of your screen, but not generic X, Y, Z directions. So they will be instead always aligned to your screen perspective view. Last but not least, there is the one that is called local. So what happens is that if you have different angles with different orientations, coordinates will follow instead the sorry, wait a second, fix one thing here. Exactly. So what I was saying, when you select angled faces, coordinates are following the orientation of those angled faces. So if I want to simply shift these angled one along its own direction, I simply click local and I can now move these along its own slope, basically. Okay? And last but not least is that instead of, oops, sorry, I went too fast. Give me a second. Last but not least is this. When you edit your freeform and you have this dialog box, last but not least is this. When you select something, you need to see that here there is a symbol that it is automatically turned on, and it is this one that is called locate. What it means, locate? Locate simply means that you apply the transformation to your object, and you will really move, rotate, or scale your object. But if you want something that is quite common and quite useful to do is, you can change the edit extrude. So you can click extrude instead, and basically we are enabling this feature that now is also highlighted in blue. So what happens now is this. Look, if I move an object, instead of moving that plane, you will see that you will instead extrude that polygon. If you rotate, the same. You won't rotate your original object, but you will extrude and then rotate a new polygon. So if I keep doing these, then I can click extrude again, and if I move it, I won't move my original, but I will extrude, and I will move my extruded polygon. Okay? And when I want to go back to more common editing mode, just have to click locate, and again select the object and click OK here. Press escape. Oops! Sorry. It was very nice. Let me do it again. 1 second. I said I extrude and rotate. Then I move like this. Perfect. Then I click locate and OK. Boom. And I have finished. If I edit the form, again, by default, remember that you always are into locate mode. So by default, you modify your existing polygons. So you can scale this, you can scale that. And when you make a transformation, if you click escape, or if you press these red X, you won't apply any transformation. Look. But if I edit the form and I do this, but then I click this one, I basically cancel the transformation. But if I make a transformation and then or I click OK here, or I click this green check sign in there, boom, I also obtain that I really apply that transformation to my object. Last but not least is this. Look, there is soft modification here. And again, this is a concept that you can already see in 3ds Max, because let me show you with a vertex. But look, if I move a vertex, you can notice that this vertex is changing its position, while all other vertices are not changing their position. But if I click soft modification, what happens is that I can tell, look, this is the object that I want to move. But I can specify that inside a certain area, inside a certain radius, that is the value that is written here, my transformation will also influence other objects. And the bigger is these, the more objects I will go to adjust. So let's say I write, I don't know, 150. Oops, 150. Perfect. And you can see that vertices are selected, but they have a slightly different color. The one that I'm really moving has a perfectly vivid red color. The further my vertices are, the slightly pinkish they will become. But in this way, if I move them or rotate or whatever else, I won't move or transform just my selected vertices. But with a decreasing amount, I will also modify vertices that are inside the range that I have written here. Then I click OK, and this is how my weird looking box is right now. And before showing you a few more interesting elements that I want to show you inside edit form, what I want to show you is that right now, if you notice, we are still in an environment that is showing us that our object is purple. So we are still inside freeform. When we think we have finished our 3D form in here, we need, before or after, going back to our normal part editing mode, and when we are done, we need simply to click Finish Freeform. Wait a second. There is a question. So, does radius have a fall-off? I think you mean this. Look. If I select an object and I click soft modification, you can see that you can see this. So the object that I'm really selecting as a red color, then with the radius I select how many near elements I can influence, and yes, the fall off that is displayed as a color changing is also described in here, because fall off means that basically the way that you can influence nearest elements, and you can have it smooth, linear or spherical, and this shape simply says how much is the factor that you apply to the transformation, from the transformation of your object to the transformation of other selected elements. And with the gradient, this doesn't do anything very particular, just it simply shifts a little bit the influence of your fall off. But most important is not because you mainly work with the radius, but the fall off is explained with these three symbols. So if you get linear, is easier element to explain. It means this. Let's say you move these 1 millimeter. So your next, let's say we have 4 vertices selected. So this you move it 1, this would be 0.75, this would be 0.50, this would be 0.25, and in a linear way you decrease the amount of your transformation. This is smooth, that means instead it makes like an S-shaped curve, so it would be stronger at the beginning and very small at the end. Spherical instead means that closer transformations have a stronger effect, while objects that are further away have suddenly no transformations. But yes, there is fall off, there is here. You can also change the shape of your of number of your influenced elements, so it can be rectangular. You can just grow it instead of a distance. You can tell how many elements you want to count, or just having circular, so that would be uniform in its application. Was this the question? Hope so. Lovely. So, I was saying this. Before showing a few more tools, what is important now is this. What we have now is, as you may see, an object that has no gaps. It is a 3D shape. I mean, it looks like a pan if we rotate it like this, but doesn't matter. So what is important is that before or after, we need to click finish the freeform. And why this? Simply because when we click this one, Inventor will turn our freeform in something that we can actually use. That would be or a 3D solid or a surface. And the thing is very simple, because if our 3D model is closed, it has no gaps, it is perfectly working like mine, this will be turned into a solid. So even the color changes, because when we click finish, look, the color code in Inventor is gray and opaque for solids, and it is orange and semi-transparent for surfaces. So look here, I click finish freeform and boom, and this object becomes simply a 3D solid that is inside my Inventor project. So why these can be extremely interesting? Simply because now we are able to keep modeling our part as we really need. What it means? I will show you just a very, very simple procedure, nothing super fancy. But now we have this beautiful as well as random curvy 3D object. No? But we have studied that in Inventor we can make a lot more operations, like we can extrude, we can fillet, we can cut, we can join, and so on and so on. So what I will do now is something very basic, that is this. Imagine that this is an object that must lay on a shelf. And while I want to keep the top smooth as it is, I don't like the fact that underneath it is completely wobbling. So what I will do is very simple, that is, I will click this plane, that is the plane that I want to use in order to make my object flat. I will make a simple sketch on this plane, let's say a rectangle. I will finish the sketch and I will extrude this rectangle. So you may notice that in this way the rectangle goes up, it covers my object. This I don't want. What I want to do is I want to cut below lower part. So I will extrude first of all in both directions. And upper direction doesn't have to be so much. Just like that. But this free form is actually a solid. So I can use any interaction between solids that I have seen, that we have seen before, and in my specific case, I don't want to use union because I want to cut lower part of my object. So I will click cut. I click OK, boom, and I will see that starting from that beautiful curvy object, now I was able to make it flat underneath. I can still see that, I could do better here, so I double click the extrusion, just make it a little bit taller, like that, perfect. And now my freeform has a perfect flat face. But also we've seen that we can use fillet when we have sharp edges like these. So I can use fillet. I will select these. I just need to be sure that the radius is not too big according to the size of my object. So I will make like 1 millimeter. I click OK. Poof. And now I also have that my object started from a freeform. It has been cut by a box, and then I have used the fillet to round these small sharp edge. Or I can do better. Look, we can remove fillet and just randomly using features that we have already seen in 3D models. But for example, I can also use shell, so that I will select this flat face that we have cut. I click shell, and I don't know if 1 millimeter would be fine, not that sure. Let's say 0.5. No, it's okay. So let's try it again. Shell, select the object. No. Let's do shell. But instead of making, because I honestly don't know the dimensions that I'm using, instead of making thickness going inside, I'll make thickness going outside. Remove faces. Yes, I want to remove that face. This one. Let's see. No. Okay. Wait a second. Oh, shell. Outside. Yes. 1 millimeter. No, 0.5. Perfect. Click OK. Oh, finally works. These kind of issues shouldn't happen if you just know which dimensions you are using. But now we have created this phenomenal object that honestly I don't know what it is. It looks like a bulky shoe, seen like this right now. Okay? But what is great is that if we notice in our Inventor project, we can still see that the Inventor keeps trace of whatever step we do in order to make our 3D model. So we can see that last step that we have done is shell. We can see that previously we have used extrusion to cut lower part of our object, but this object is still a freeform. So while it is true that we can always double click to shell to change parameters we have used, double click to extrusion to change parameters that we have used, it is also true that we can double click to our freeform to be able to edit again our freeform object by changing vertices, extruding them, and so on and so on. Can I have a sharp edge instead of smooth edges in a freeform? Yes, you can, and this is why I am back to our freeform object, because in let me make this introduction. If you remember, in 3ds Max, what happens is you start always by having sharp edges, and then you need to apply a modifier that is something like turbo smooth to smooth your edges. What is interesting is that in Inventor it happens exactly the opposite. That is, by default, all of your edges are smoothed, and if you want, you can make them sharp by using this button that is called crease edges. So if you select, and inside there is also uncrease that I will show later, but if you click crease edges and then you select edges, instead of remaining smooth, you will see that you will start having sharp edges. Okay? You can, and this would be like the most dramatic thing you can do, if you select, let's say, all of your edges, just exactly, last one, ready for this? If you basically crease all of your edges and you click OK, what you obtain is, believe it or not, like a sharp editable poly in 3ds Max. Okay? Not only, if you click S instead, you can even remove the smoothness from your objects. So, do you remember when we have studied, really at the very beginning, 3ds Max, and I show you that you can make the sphere, and inside the sphere and all other round objects there is an option called smooth. The same exact thing happens here. That is, by toggle smooth, you can not only having sharp edges, and sharp edges are made by using crease edges, but you can even remove smoothness. Or you can do opposite step, that is, you can toggle smooth again, and to start having back your phenomenal edges as round edges, you can see that next to crease edges there is a triangle, and if you click that triangle you will find that underneath there is the opposite parameter that is called uncrease edge, that simply turns your edges back into smoothed edges. Okay? So inside the same object you can have at the same time edges that are round as well as edges that are sharp. These, maybe this one. No, I will keep it. And these 4 here. Poof, and you click OK. So you can combine your edges so that you can make a lot more complex shapes, not just entirely smoothed or entirely sharp, but edge by edge you can choose how they should appear. Also, you can basically do something more complex, that is, by using a few of these tools. I will show you those that are pretty useful. For example, you can use subdivide. And with subdivide, you can quickly select a face, and you can quickly select how many subdivisions you want inside that face. Okay? Like this. And you can also use simple or exact. Exact simply means that all of your selected faces will be cut by using these 2 numbers. Okay? And then let me click cancel because this would be too much. Sometimes you don't need to add a lot of faces, but maybe you need just to insert one edge. So in here you can again just select your starting edge, and Inventor will add an edge on the face that you are touching, and you can choose which side. So look, if you click here or you click there, you can have 1 or 2 edges from both sides. You can't instead select which side. What it means: when I click single and I select this one and I click OK, this edge adds this one. But if I wanted simply a new edge here, instead of selecting this one, I have to select this one. So if I go back and I delete also my sketch, if I wanted a new edge in here, I simply need to check which one I have to correctly select. And don't ask me if you can choose left or right, because you can't. You have to check it. Okay, so what is next to insert edge instead? It is insert point. So you can simply click along existing edges and you can add new vertices. Okay? When you click OK, oops, why? Insert point here. Okay. Now, if I go to edit, I will see that here I have my new vertex, and I can edit that additional vertex. As well as insert point, insert edges, or subdivide, I can use weld vertices. So if I select, let's say, these vertices, they will be attached together like this. And you can weld them vertex to vertex, or you can use weld to midpoint like it happens in 3ds Max. And you have removed that vertex. Or, let me show you again, look, you can click weld to midpoint, so that if I select these and these, poof, they will be welded in that point that was in between them. I can also add more vertices, and I click OK, and I have basically combined all those vertices into one center vertex only. Last but not least is that you can merge edges, and let me tell you, merging edges is basically the same. So instead of working with vertices, you work with edges. So you select set 1, let's say set 1. Why is it not working? We will see this another time, because it's not working and I don't know why, honestly. But what is more important is this. If you want in your object, you can also use delete. So what you're going to delete? You click delete and you can delete points, you can delete edges, you can delete faces. And according to what you select, you may have something that will keep the object as a solid or not. What it means? If I, let's say, select this vertex and I delete it, not a big deal. I just lose the possibility to control that point in this round face, and I lose also all segments that were attached to that vertex. That's okay. But my object is still a solid object. There is only one thing that you have to know, that is, if you delete, but you delete faces instead, and you do this, you click OK. It's even failed. Let's see if I can delete this. No, so let me go back. Okay, let's see if I can delete it now. But if you delete a face, hopefully I can delete these. Perfect. Now see what happens. By deleting a face, take care, because your object won't be a solid anymore. If I click OK and I finish the form, take care, this object that is hollow inside and it has no thickness, this is going to become a surface. So it won't work as a solid. So, I mean, just be aware, because when you go back to your previous part, maybe it won't work. So let me read your question again. That is, if I want something in between sharp edge, insert an edge near to edge. Wait. Let's recap. If I want something in between sharp edge and smooth edge. Do I have to insert an edge? Insert an edge near to the edge. If give me 3 seconds more to review again this question. I want something in between, sharp and smooth. Insert edge. If I want something in between. I mean, Italian if you prefer. I mean, it's the same. Try in Italian. Let's see what happens. But in the meantime, let me see if this is what we need. So, if I want something that is not in the center, but if I want something nearer, like this. Here. Is this what you want? So if you don't want the edge to be in the middle, but if you want it to be closer to another edge, is this the question? Wait. Suspense. I mean, we are all waiting for you. Ooh, suspense, thrilling moment. I mean, no, I don't want to continue anything because I have almost technically I have almost done. I would like to spend 5 minutes in explaining what is going to be your homework. That would be phenomenal. So we have time, don't worry. In the meantime, let me explain which is going to be your next homework. That would be this. This would be a little bit complex, and I mean, can I have just Google here without any news? Yes. So, let's see this. Yes, whatever. What we have to do is what you have to do is this. You need to design one object, and you need to design this object in one part only. And for now, because next week we will start speaking about assemblies, so I will give you 2 weeks for these, and next I will give you a more complex object that will involve more than one part, of course. And quando apri un tubo smooth, wait, in the meantime I read the question. Quando apri un tubo smooth a un cubo ottengo una sfera. Yes, 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 yes. This is exactly what we were doing here. Look, 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 look. Let me finish this freeform and hoping. No! Phew. I was scared it was about to crash, but the problem is that it is weird now. So let me delete these. So what your classmate asked is basically this. If I make a box or whatever other shape, because they are all the same, and what happens is this. When I have smoothed objects, it makes a lot of difference where my additional edges are. So what it means, if I insert an edge and I place this edge right in the middle while my object is smoothed, what happens is, of course, it slightly changes the curvature of my corner here. So if I keep inserting another edge in here, this corner that now is pretty rounded, pretty smoothed, by adding this edge, what happens is that this will be slightly less rounded now. This is something that depends not only in how many new edges you add, but also it depends on where these edges are placed. So when we click insert edge, you can see this location that is called 0.5, and this would be even better to be understood. Look, if I click both sides and I click 0.5, 0.5 means that let me change the color here, means that this is my selected edge. This is polygon that is attached to it. This is polygon that is attached to it as well. So my new edges will be exactly at 0.5. That means in the middle of this face, If I decrease instead this 0.5, let's say I make 0.1, you will see that my new edges will be closer to the corner, to the edge that I'm selecting. So if I do these, when I insert maybe 0.1 was a little bit too much, but what I do is exactly what your classmate asked, that is, I can have vertices that are smoothed but not as sharp as well. So not only I can drastically use uncrease edge to have perfectly sharp edges, but I can also control the amount of my smoothness by using the insert edge. So if I insert this one, and I say like 0.1 in here, poof, you will see that this is still round, but not as round as before. Or we can also tell that is, a little sharper than before. Okay? Is this what your question was about? Perfect. So let's go back to the homework now. And I just have two options, and we will make a poll, and you have two options. Option number one, design a how to say in English, no coffee pot, a coffee cup. So why Bing? I was using Google. So option number one, designing a coffee cup by yourself, not something that is already existing, but I want to see sketches that you make by hand and the result in Inventor. So this is option one. Option one is coffee cup. Option two, that I honestly think is not the right time, because it maybe is something that we can do after showing, after viewing, how can I say, assemblies. There is a mouse, like something like this. Even if I think this is more for when we will explain different parts that can be assembled together. So I will write into the chat, vote for coffee cup or a mouse. Vote now, and democracy wins. You will be the one that will choose your next homework. Do it. I mean, I can't say hands up because I can't see your hands. Woohoo! So coffee cup, lazy you. I knew that. Exactly. Okay, so homework. Next homework is very simple. Next homework, democracy wins. Next homework will be design an original coffee cup. So be precise, spread the voice, tell this to everyone. When you will upload your next homework, I would like to have at least two files. One will be the Inventor file. One will be at least just a picture of your preliminary sketches. Okay, so I will also write, and you have 2 weeks. In 2 weeks, you must upload Inventor file and a picture of your preliminary sketches. I'm writing these on the chat because if you probably watch it and again the stream, I probably think that you can also see how the chat was working. But I will write, once that I will stop this live streaming, I will put link in the description in order to upload your homeworks, and I will also copy and paste these two messages so that in the description of my video it will remain even which is your next homework. Okay? Do you have any other question? Because if not, I will stop and we will see each other virtually next week. Perfect. So, as usual, who's there? As usual, like and subscribe, and we will see next week. Ciao.